Hi guys, welcome to another video here. What we're going to look at today is how to convert units, which is a very valuable skill as you work your way through your mechanical science lessons and also in your careers in engineering. So we're going to concentrate mainly on the metric system of measurement today, but we'll do a bit of a recap on engineering notation first. So I'm going to pop a few examples up here. Now these are the most common examples of engineering notation. As you can see, we've got the micro, milli, kilo, mega and giga, and as you work your way across here you can see what they represent in various different metric units. Now we're using meters as a common example, but 10 to the minus 6 you can see is micro, milli 10 to the 3, kilo represent 10 to the minus 3, sorry I said, 10 to the 3 is kilo with capital K, mega 10 to the 6 capital M, and giga 10 to the 9 capital G. Now if you're getting a little bit confused with these, if you have a little look at your calculator, you can actually see it's got an ENG button on there, and that represents engineering notation. So an example, you do a calculation, you've got a big list of numbers. If you hit the ENG button, it will take it into standard form or engineering notation for you, and that will go up in values of 3, 6, 9. Right, so if you want to go down 10 to the 3, you hit the ENG. If you want to go up, you hit Shift ENG, and that will change those units on the end for you. So a really good tool to use there. Okay, first job, we're going to transfer millimeters to meters and vice versa. So millimeters, as you'll know, there is 1000 millimeters equals 1 meter. Alright, so what we need to do is we need to take this 50 and divide it by 1000 to transfer it into meters, and what we'll get is 0.05 meters. Now that is the same as doing 50 times 10 to the minus 3 meters. Okay, so 0.05 meters is equal to 50 times 10 to the minus 3 meters. We'll come on this side, we'll do the exact opposite of that. So we're going to go the opposite of divide, we're going to multiply. So we'll get 2,400 millimeters. Okay, particularly it comes in handy if you're given sort of things like diameters. So if you're given a diameter of 20 millimeters, yeah, then we need to be able to transfer that into meters so we can apply it into various different formulas. So we go 20 times 10 to the minus 3 meters. Okay, and then if you might be given a calculation and you find your answer at meters and you've got to transfer it into millimeters, if you multiply that by 1000, that'll do that for you. Okay, next one. Milliliters to liters. Again, same applies. There is 1000 milliliters in a litre. So we've got 100 milliliters. We'll divide that by 1000, and that will equal 0.1 litres. Again, the same principle applies. If we put 10 to the minus 3 on there, that will also equal 0.1 litres. So again, a few different ways you can work this. Same as with the millimeters. We've got 2.1 times 1000. Again, this 1000, it's a common theme. It's 2,100 milliliters. Okay. Grams. You can see a pattern coming here. Grams to kilograms. Again, 1000. So we've got 0.024 kilograms, which is equal to 24 times 10 to the minus 3 kilograms. Opposite side, 1.2 multiplied by 1000 is equal to 1200 grams. So again, it comes in handy if you're given information in grams, particularly when it comes to density, is a common one where we're using grams. You have to transfer it into kilograms before you can apply it into any calculations. You might find a value in kilograms and then have to transfer it into grams as part of your answer. Right, this one's slightly trickier. We're taking kilometers and turning it into meters per second, which is commonly used in our velocity. So we're going to 20, taking kilometers to meters, we need to multiply it by, yes, you've guessed it, that 1000 again. Okay, but that's not finished there. We've taken that and we've got 20,000 meters per hour. So how do we get from hours to seconds? then what we have to do is we have to divide that by 60 minutes times 60 seconds, which is obviously 3,600. So we'll have a look at 20,000 divided by 3,600, and we'll get an answer for that of 5.5 meters per second. Now we can actually simplify this, so by taking some of these zeros away. So what we can simplify that is we can do 20 divided by 3.6. We can move the decimal from here over here. We can take our 3,600. Yeah, I'll put the decimal there. Cancel them ones. Cancel that. So 20 divided by 3.6 is equal to 5.5 meters per second. So making it a bit easier for us. So all I suppose you have to really do is remember that 3.6 and you've cracked it. So let's go the opposite way now. So let's go for 45 meters per second. So we multiply that by what's on the bottom, 60 times 60, and then divide it by what's on the top on the other side, 1,000, and we'll get an answer in kilometres an hour of, stick in your calculator if you need it, 162 kilometres an hour. Well, this same principle applies here where we've done this cancelling thing. So we can simplify this by 3,600 divided by 1,000. You've guessed it, multiplying by 3.6, and then we'll get an answer of 162 kilometres an hour. So kilometres to metres times 1,000, hours to seconds, divide by 3,600, and the reverse on the other side. Next one. Angular velocity, commonly used RPM, revolutions per minute, or to do anything with those information we need radians per second. So you remember from our sessions that 100 RPM is equal to, 1 RPM is equal to 2 pi. So what we're going to do here, we're going to multiply this 100 by 2 pi, and we're going to divide it by 60, because 2 pi in each revolution, 60 seconds in each minute. So we'll get an answer here of 10.47 radians per second. Okay. Now, opposite side of that, we're going to go reverse of this. It's the same as we did on the previous question. We're going to flip those values. So we're going to have 35 times 60. Because we're going from seconds to minutes, so we're multiplying by 60. I'm going to divide that by 2 pi, which is equal to, stick in your calculator, 334.22 RPM. Okay, so we've got lots of examples of different units, transferring them into the metric system of measurement, and the final example we've got there is about angular velocity. So again, make sure you're using these as you're working your way through. It's really important we get the units right before we perform any calculations. But any questions or queries, give me a shout, and once again, thanks for watching. I'll see you in the next one. Bye bye.